So in the last video we completed our own myQ class and we were able to declare the properties front pointer, rear pointer, because a Q needs 2 pointers, and a space for the array content. So went for a char array. We could have picked anything. Built our constructors and the methods on Q, DQ, peak, size, empty is full. And now we were going to go from just making a linear queue, which in the way that we did it was really poor because it ran out of space on the array. We're going to go and make our circular queue. So our circular queue, we left off with this design and we made all of this. And the additional OOP features that you'll get to see in this video are inheritance, because we're not going to make an entirely new class for our circular queue. We're going to build on what the myQ class is. We're going to take it from there. We're going to inherit the attributes and methods of that class and have them in our subclass or derived class. So yeah, inheritance is the ability for one class to take on the properties and methods of another. The class that is used as the basis for the inheritance can be named superclass or base class. Also there's another name as well. It could also be called parent class. And the class that inherits from the superclass, the parent class or the base class, is called a subclass or derived class, or finally child as well. So you can have parent and inheriting from the parent a child class too. These are all that's all the terminology that you will get with inheritance. Superclass, base class, parent, and subclass, derived class, and child. You'll see all of that on the internet. My preference is to use base and derived, but superclass and subclass are often used in things like Java. And parent and child just makes good use of the fact that this is called inheritance, and well, we inherit from parents. We inherit our attributes: hair color, eye color, skin color, other genes, not just about colour. We inherit them from their parents, but it's not a great analogy because as human beings we tend to inherit from two parents, whereas inheritance in programming, you can only inherit from one class at a time. And polymorphism we're going to see. So the ability to redefine the methods for a derived class. So we're going to have to redefine some of these for our circular class, because the circular queue class, because these just won't work for us in there. So why won't they work for us? Let's have a look at some special cases. So if the front pointer's there and the rear pointer's there, the rear pointer is, well, we've got to imagine that we don't have anything in there. I shouldn't have written anything there. And the rear pointer is there. We're going to say that this is a full queue, because the way that we've implemented it, we've got the rear pointing to the next free space. And if we implemented it in such a way that we filled this space with H, let's say, the rear pointer would move, increment, but because we can't actually increment to there, it would wrap around and be here. And if we had a situation in which the rear pointer and the front pointer were pointing in the same situation, that's empty. So we're going to have to redefine redefine is full. We have to redefine is full because it's not going to work the same. We're going to also, as well as just checking whether the rear pointer is equal to the array size, we're going to have to make sure that the rear pointer jumps back around to the index 0 to form that circular queue to go back round. In the case of this, we'd also want to check where the front pointer is, so making sure that the front pointer isn't there already, because if the front pointer was there, then we'd end up with an empty queue when it's clearly not empty. In fact, we've just added a new item. So is full needs to be corrected. But if we look at is full, well, is full is actually used in the onQueue method. So it could be that we redefine onQueue and make sure that we don't end up in the situation where we have the pointer of the rear going to the same place as the front. And the same has to happen later on. Say we add and remove some stuff later on and the first pointer here, and we've wrapped around and we've got the rear pointer here. We don't want to end up in a situation where we add to the list and the rear pointer and the front pointer are at the same place, because we'll end up with that being empty. So the rear pointer, we need to check the rear pointer versus the front pointer. Is the rear pointer equal to the front pointer minus 1, or is the rear pointer at the end location and the front pointer at 0? Those are the two conditions we're going to have to check for is full on a circular queue. Is empty should be able to remain the same. Is empty should be good wherever the front and the rear pointer are equal to each other. The queue is going to be empty, so we shouldn't have to make any changes there. Dequeuing, we will have to make some changes because of the situation where the front pointer is here. Let's just say that the rear pointer is there. So once we dequeue the H, so we take a copy of the H and then increment the front pointer, well, that's pointing to nothing now. We need it to wrap around back to the start. So we'll need to do an additional check to make sure that the front pointer can, or additional lost it now. Additional code to make sure that the front pointer in that situation does wrap round to the front. We shouldn't make changes to peak because it should remain the same. And size will have to change for our circular queue. We will have to make a change here. Let's look at this situation here where the front is here and the rear is here. Well, how many things have they got? So they've got 1H, 1A, 1, 2, 3, 4, and that's pointing to an empty space, so not really looking for the D. So that's a size of 4, but if we left it with the rear, it was the size, I think we calculated it as the rear minus the front. Well, the front is now pointing to 7, and the rear is 0, 1, 2, 3. So it ends up being 3 minus 7, which is minus 4. How many items actually are there? 1, 2, 3, 4. So maybe it will work if we always just take the absolute value, and the absolute value is going to be the distance away from 0. So I think about a number line, 1, 2, 3, and then 4, and the other way, minus 1, minus 2, minus 3, minus 4. The absolute value is the distance away from 0. So although it's minus 4, the distance away from 0 is 4. So we could take the absolute value, so we can still do the same calculation, but just take the absolute value that we get back off it and use that. Will it work in all eventualities? I think it might do. We'll test that out. So we will need to do something with this or redefine it. Use polymorphism for the onQ, dq, size, and is full. So we're going to be inheriting from this class and using polymorphism to redefine some of these so they'll work for our circular queue. Okay, so before we go and start making our circular queue, we probably want to adapt our existing queue. So the adaptations to the design that I'm going for are changing the access modifiers of the front and the rear pointers. So the hashtag is going to define for me a protected spelling here. Protected attribute, and a protected attribute is essentially private, so it can't be accessed from outside the class, but it can be accessed by any child classes, by any subclasses, by any derived classes. So this will be private, that we can't access it from outside of my queue apart from in the inherited class that we're going to be making in a moment. So we can access those. I don't know why I've colored that in, I apologise. onQ is public, so it's still going to be public. And dq is public, so it's still going to be public. So it's going to be accessible from outside the class, and it will still be accessible in our derived class, our child class. Not sure why I changed that. And the same with size. That was public already. So we won't be making the adaptations there. Public except accessible from outside, and also accessible from any child classes. Full, however, was private. It was minus there, so it is going to be protected because we said that we would be updating that one, because the is full. Is full is a little bit more complicated now. We've got a circular queue rather than just a linear queue. We've decided to keep the queue contents private, so they are only accessible from my queue. I don't believe just changing the queue will be necessary. And now, as I say it out loud, I'm starting to think it might be. We'll see. We'll come back to that one. We'll question that one, whether we need to make that protected as well. For now, we're just going to go with the two attributes, front and rear pointers, as being protected and is full. We're going to change that to protected. So the three access modifiers: public, private, and protected. Public, accessible from outside the class. Private, not accessible from outside the class. Protected, only accessible from any child, derived, or subclasses. Okay, so we'll go and make those changes now. So we'll go straight to our code, and our pointers, we're going to make them protected. Okay, so they are now accessible from outside the class for any derived classes, for any child classes, for any inherited, any classes that we're going to inherit my queue. And we're doing the same with is full. We're going to make that protected. Excellent. So that allows us to then go and try and make our circular queue design. So our circular queue design here, we can see that we're going to be inheriting from myQ. So in C#, the way to inherit, we're going to have the semicolon, and we're inheriting from myQ. Notice that there's no additional properties. Our circular queue is going to have no additional properties. It's going to use the ones that are in the queue already. So the front pointer, rear pointer, we can access those in here because we've just made them protected. And it is going to have some of its own methods. It's going to be using polymorphism to override the methods in the parent class, overriding the onQ method, the dq method, the size method, and the isFull method. So we're building on our existing design and making it, or changing the methods. So we're using inheritance and polymorphism here. So we go back to our project and we're going to add a new class. And we'll follow our design, so we're going to call it my circular class. My circular, not my circular class, my circular queue. My circular queue, there it is. We're not going to have any properties. We are going to have a constructor. And the constructor, again, it's going to be a public method with the same name as the class. My circular queue. We forgot to include the inheritance, so there's the inheritance. My queue inheriting. The constructor, and it doesn't like it because we're requiring a size in myQ. myQ, when we create the constructor, requires the size. And this constructor is not going to have anything in it. All that this constructor is doing is enabling us to construct my circular queue and then call the base constructor with the size. So we can make a circular queue of a particular size. So let's say if we made a circular queue of size 8, we'd pass in 8, and in the base constructor, because we're inheriting all of the attributes and methods from the myQ class, it would send the 8 into here and construct the queue. Okay, but there's nothing in addition that we need in here right now. I'm just going to shorten it a little bit and just put the open and close braces. Okay, and we do have, however, some methods that we need to implement, and implementing our polymorphism. And while we're back in the Q class, the parent class, we're going to make some of these methods virtual to allow them to be overridden in the subclass. So we wanted onQ, dq, size, and isFull. Okay, so with that keyword, they're all able to be overridden, and in our circular queue, we can then create those. So public override, so the keyword to go with virtual, show that we're going to be overriding and using polymorphism, and it comes up with things to help us as well. So first up we'll do onQ, and by pressing tab when we selected that, it essentially creates it for us. We are calling it the same. That's the polymorphism side of it, that it'll, in my circular queue, if we call onQ, we'll do this as opposed to the other one. So onQ, what's it doing? Well, we're taking in a character, and then what it's doing here, base onQ, well, that's looking at the base class. The base class onQ, which asks if it's full, and if it is, overflow error, else queue contents. Now we need to change this on a few aspects. We need to make sure that the rear pointer, when it's incremented, it does have that wraparound back to the front. So we can still have it execute this onQ, and then afterwards we want to look at what the rear pointer is and see if we need to wrap it around. And this is where I said earlier in the video that we might want to make the queue contents protected, because if we do not have access to this, we won't know what the size of it is. So we are going to make that protected in the end. So we're changing our design as we go along. So making queue contents protected so we can access it in here. So if the rear pointer, which we can access it because it is protected, if it is equal to the queue contents.length, which again we can access because it's protected, if it's equal, then the rear pointer needs to equal equal 0, not compare to 0. And that should be about it, because we are going to come on and change and override the is full option, and I hope it would then call that. We shouldn't have to do anything there. It's just checking that the rear pointer wraps around to the front. That's the onQ done. And what's next? Well, we've got public DQ, and we're going to be overriding. And again, it comes up with options for us. And we're going for DQ. Press tab, and it automatically creates it for us. So at the moment, it's returning the base DQ. It's definitely we want to do. Let's go and have a look at the method that we already have. We already check if it's empty. We were making absolutely no changes to the is empty method. That was fine. And then it takes a temporary copy where the front pointer is, increments the front pointer, and then returns that temporary copy. Now in our DQ here, we want to make sure that if the front pointer is at the end of our array, it wraps around to the front. So we can't change the front pointer or check the front pointer before we've actually DQ'd. So again, we're going to take a temporary value here. I'm going to temporarily take a copy of the DQ. So take that out. Keep a copy of it, and then we're asking if the front pointer, it's a good job we went and made the queue contents protected, so now we can use it again. If the queue contents.length, the front pointer equals the queue contents.length, then the front pointer needs to equal 0 to wrap back around, and then finally we can return that temporary value. So it allows that front pointer to move in a different way. Instead of just incrementing, which when it gets to the end of our array, can't increment anymore. When it gets to the end of our array now, it sets back down to the start of it. So we've overridden the onQ and the deq. Next up we need to override the size. So public override again. Let's see what options come up. Well, we've got size on our list. Now, in our design, we talked about the rear pointer minus the front pointer would get us the size, and then explained that actually when the rear pointer wraps around, does that give us the amount of items in our queue? And I just want to go back and test a few cases out and make sure that it does if we find the absolute value. That's what we're going to go and do now. So never be afraid of going back and redesigning, trying things out. It's the way that we're going to get better and improve. I perhaps could have done a better job of doing it before the video though. So we've got our front pointer here and our rear pointer here. So if the rear pointer is always pointing to an empty space, well, officially the D there doesn't exist. So we'll have 1, 2, 3 items and then this empty space. And well, in fact, all of these empty spaces. As far as we're concerned. So yeah, 3 items in the queue. The front pointer would be at 0 here, the rear pointer would be at 0, 1, 2, 3, at position 3. So does our formula of the absolute value of R minus F work? R minus F does give us 3 in this case. Right, let's presume that the rear pointer has come around and is now pointing here, so it's gone, we've filled it up and we've wrapped around, and our front pointer is here. How many items have we got? Well, we've got 1, 2, 3, 4, 5, 6, and then that's an empty space and that's an empty space. So we'll look at what our indexes would be. Well, this R would be index 1 and F would be index 1, 2, 3. So we'll have a look at our formula, R minus F. So R1, F3, well, that'll give us minus 2. Even the absolute value, which would be 2, doesn't account for how many we have. So we're going to have to come up with a different formula for working out the size now. Now we've got this circular queue and we're wrapping back around. This formula certainly works if F is less than R. So we could start there. If F is less than R, we can use this formula to work out how many items are in there. However, if F is not less than R, if F is in fact greater than R, if it's greater than R, what are we going to have to do? Well, it will be the size of the array minus R minus F, or plus, if we're keeping it that way, because F will always be greater. Look at this case, so the size of the array is 8 minus the 2 that we get from the subtraction of F and R. Does it work? Well, let's do another case here. So if we move F up by 1, so F is 4, and R, if we just stick it back at 1 again. So the size of the array is 8 still. R minus F is minus 3. That gives us 5. Size of 5. 1, 2, 3, 4, 5. That's the empty space. Yeah, so that formula seems to work. So we're wanting to subtract F from R, and if it's a minus number, we need that negative number to be deducted from, or the negative number to be added to the size of our queue. Okay, so we are going to change it up a little bit, but let's remind ourselves of what the base does. The base method just subtracts the front from the rear. So if that's already doing it, and we're happy that that does it well, then there's no need for us to change that aspect of it. So int diff, standing for the difference. So we'll still call that size. So F minus R, the front pointer position minus the rear pointer position, and then if the diff is less than 0, then we need diff, or the size. Well, I'll keep it as diff. No, I won't. I'm going to make a new variable called size, setting it equal to 0. Just think this through. The size equal to the F minus R, and I don't know what I'm doing here. I shouldn't have called it diff. Diff's confusing me. If the size is less than 0, which we can't have a queue that's got minus items in it. If the size is that, then the size is actually going to be the length of our queue, contents.length, plus size. Now, if size gets to this point, it's less than 0, so it's going to be taking away whatever size is from the length, and then we can return that particular size. So yeah, even something that seems quite easy is actually turned out to be quite complex. And lastly, we need to work out the is full. The is full. So that's what we'll do next. Public. I think we left it as private in our design actually. Private override. We might not be able to do an override if it's private. Well, maybe. I wonder if we have to change it to protected. Yes, it's got to be the same access modifier as the one above. So the is full protected, so that changes our design a little bit, but that's okay. Is full protected override bool, and currently is full works by checking if the rear pointer is equal to the queue length contents. Now when we looked at it earlier, we saw that there'd have to be another instance. So yes, it could be full there if F is also at 0. Otherwise, we also need to make sure that R, if it is equal to F minus 1, then it is full. So they were our two cases. So in this case, we're not going to call this one because it's entirely different this time. It's not the same code that we're doing. So we're not going to call the base in this case. So in the previous examples, the onQ, dQ and the size, we could say that they still had a job to do in the parent class. They still had some code that was useful, and we just had to add some additional code for our circular class. In our isFull, it's a bit more complex, a bit different, and it wouldn't be any benefit to us from running the base class. So we're just going to completely override it, and if we run this one, it doesn't run the parent one. So if statements again, if the rear pointer is equal to the Q contents.length -1. So in our example, if it had size of 8, if the rear pointer was at position 7 and front pointer is at 0, that means that we can't wrap around the rear pointer. We wouldn't be able to enter some data and then have the rear pointer increment and wrap around to 0 because the front is at 0. So in that case, we need to return true. It is full. It is full. And if the other case is that the rear pointer is just behind the front pointer, the rear pointer is equal to the front pointer -1, then we need to return true as well. If it's not either of those scenarios, then return false because it's not full. Okay, so two scenarios. The rear pointer is at the last index and the front pointer is still at the first index, so it can't wrap around. And the second one, if anywhere in the middle of the array, the rear pointer is equal to the front pointer -1. So if the rear pointer is just one value less than the front pointer. So again, we'll have a look at here. So the two cases, the rear pointer is already at the end point, so if we added something else, it would have to wrap around to the front, causing the queue to appear to be empty because the front and rear would point together. And secondly, if the rear pointer was one less than the front pointer, if we tried to add something then increment, the rear and the front would equal to each other again. So those are the two test cases that we're using. Okay, so all that's left is to try and test this out. So go back to program. Now we did a lot of tests for our original queue. Just going to move them into a subroutine of their own, just in case we ever want to go back to them. Static void queue test. So we can always call that and test that again. In fact, we might as well do our circular queue test as well in another subroutine. Circular queue test. So our circular queue test, well, we've got my circular queue. We'll call it circular queue equals new circular queue. So it's calling the constructor. Let's keep things of size 8 so it matches our our demonstrations, our examples. So that forms creates a object called circular queue, an object instance of the class, and then we can start going about testing it. Circular queue. And we can do, I suppose we could try and do a very similar test to what we had before. So we could copy these tests and just change them out for instead of queue, circular queue. And then we need to go back through and adjust whether we think that it will actually output the same thing as the linear queue, or now because it's circular queue it will output something different. So if we keep it the same as it is, same as the queue was, it would have made more sense just to call this circular queue, but we've done it now and we're changing everything. And so we've made all of those changes. We could have used find and replace to make it a bit quicker, but we're done now. So if this was a circular queue, were we still looking at the same sort of thing? So we check the size. I would expect it to be 0 initially. I would expect us to not be able to dequeue, and it should error and underflow. Just check that. What is this? And the dequeue. Possibly not. Possibly have to do another check. I think when we had an error, we just sent back a space, so we can check that the temp is not a space as well, and temp is not equal to space. And I think very similar thing for the on queue. We do kind of need to have some way of checking whether it did on queue it before changing the rear pointer. Although, no, sorry, ignore me, because the front pointer wouldn't have changed if there was an error, so we don't need to do any additional checks. No, apologies. So, right, let's start again. So the size initially 0. If we try and dequeue, we should end up with an error underflow. Circular queue on queue, so we should be able to on queue A, check the size, it should be 1. On queuing B and C, the size should now be 3. On queue D, E, F, and G, the size should be 7 at that point. On queue H, size should be 8. And then when we try and have something else being added, we try and have I being added, we would have gone beyond the bounds, so we shouldn't be able to do that. Then we check the size should still be 8. We dequeue A, the size should be 7. In fact, we should just run it exactly the same and check that it does work the same so far. This won't obviously check any of the circular operations, but we can change that in a moment. So what's happening? A, B, C, D, E, F, and G and H are getting put onto the queue, and then we're checking along the way that the size is correct, and then we're dequeuing, peaking, checking the size. It should be identical. Let's give it a check. Oh, we haven't called it. So this will be the most pointless program. Yeah, we didn't actually call it. So it's circular queue test, and it's going to jump down to this method here and run these tests that we've just renamed. And did it work as we intended? So we've got the comments to help me. 0, empty, size 1, size 3, size 7, yeah, matching. We got an overflow error when it was size 8. Okay, so that's slightly different to when we ran it as a linear queue. I think it's because I'm maintaining now that the queue has to have an empty space between the rear pointer has to point to an empty space now. So it's actually, we're only ever going to have a possible amount of one less than the array size. So that makes sense. So that's overflow, because we've tried to add twice now when it's already full, or when it's one less than being full. Dequeuing A, so it's still coming off in the right order and it's still reducing in size. Dequeuing B, C, D, E, F, and the size goes down to 1, and then it's just G. We dequeue G, and yes, we've now got empty errors. So there's no crash, which is positive, and we've just noticed that we're going to keep that one empty space at the end, but no circular action going on. We didn't see it wrapping around. So we're happy that this is working as a general queue. Now we want to kind of test that it is going to be working as a circular queue. So what we're going to test for that to happen, I'm going to start again. So I'm going to do a lot of onQueues. Queue.onQueues. So I'm going to stick to our format of just sticking A, B, C, D, and then we know the order's correct. A, B. Could have done this a much nicer way now. Regretting having typing it all out. So A, B, C, D, E, F, 1, 2, 3, 4, 5, 6, 7. So then that would be full. That would be error. And then I want to go about dequeuing this stuff. So dequeue dequeue1, and we're going to, it's the circular queue we're dequeuing from. So we're anticipating that will give us A, because A was the first thing in, and every queue should be first in, first out, with the exception of priority queue, which is still first in, first out, but with some extra touches of priority. So if we dequeue A, we should then be able to onqueue H, because now the front pointer will have moved up 1, so the rear pointer could wrap around. But then if we then try and onqueue I, it shouldn't let us, because the rear pointer would be 1 less than the front pointer. So we should get an error there. We should test sizes as well, just to make sure. size is working. It seemed to be working and matching up with the Q test that we had before. So size 1, and it's circular Q, not Q. And we anticipate that being 7. Do another size test after we try and on-Q, and it should still be 7. After we DQ, hopefully it's gone down to 6. So size test 3, 6, and then if we on-Q H again, size test 4, it should go back up to 7. And then we error as we on-Q. And we should then do a few DQs. DQ2. And we expect what from DQ2? Well, we've only taken A off, so we expect B to come off next. DQ3, we'd expect C. DQ4, we'd expect D. DQ5, we'd expect E. DQ6, we'd expect F. DQ7, we'd expect G. Now H wasn't put on originally, but hopefully it will be by that point. After we've DQ'd A, we should be able to DQ that one, so DQ8, and that will prove the circularity of this Q, because we weren't previously able to add an eighth character, but now we can. So H should be able to be DQ'd, and then it should be empty again. So we can DQ 9 and expect an error. Underflow. And we can check the size again. In fact, we can squeeze in a few size checks in between all of this. So once we DQ a few, size check 5, and what are we expecting? So we've added A, B, C, D, E, F, G. We added 7 things. We DQ'd one of them, then we added one again, so we expected 7. And then we DQ'd 3, so we expect 4, which would make sense given that we're expecting to be able to DQ 4 things afterwards. We'll do a size check again here. So size check 6, sorry. And we'd expect, if we had 4 things there and we took off another 3, we'd expect 1 thing. Then a H, attempted to DQ, and this size check of size check 7 now, isn't it? And we expect it to be 0. And just because I'm interested, I'm going to put a breakpoint in here to see where the front pointer and rear pointer have got to. And with all of this, guys, you could slow it down a bit more and actually draw out the array and where the pointers would be to go along with this. I realise I might be going a bit quickly for you, being able to work this all out in my head, because I'm visualising my stack in my head. But it could be beneficial to do it on pen, paper, or on something where you've got the stack and not stack, they've got the queue, and you're identifying where the pointers are going and what data's on it, to help you out with this. So fingers crossed this will go well. So we'll give it a run. Okay, it did stop at my breakpoint. I just want to see the output up to that point and see if it matches what we said it would be. So we expected 7, then an error. That's what we got. We got 7 again. We got an A coming out, dequeuing A. Fantastic. And we expected to output 6 and then 7. So you see the size went down when we dequeued A, and then we onqueued H, and that increased it to 7 again. So that H must be in index 0. Of course, we will be able to check that in a second. We expected an error when we tried to have I, so that matches. Then we expected to dequeue B, C, and D, and the size to be 4. So this is working out very well. And dequeuing E, F, and G, it did dequeue E, F, and G. The size went down to 1. There's only one letter left, H, and then we got an error. Sorry, I lost it there. And when we tried to dequeue, we got an error, and we stopped at the point in which we were running this line of code. So if you didn't already know, down this left hand side you can put breakpoints in, little red circles. That will stop the code and allow you to go through one line at a time. There's some controls up here. Step into allows you to follow through the code. So that's what we're going to be doing now. So following through. So it called size, and size was the method that we made in our circular class. The first thing it goes and does is call is the base size. So if you're ever struggling with what a piece of code does and what is happening, you can always put a breakpoint in and go through slowly through your code. So it calls the base size, and that's going to return the front pointer and the rear pointer. They happen to be 0, both be 0. So 0 minus 0 is just going to be 0. So it returns there. And if size is less than 0, which it isn't, it returns it. So it returns 0 for us, and 0 is what we were expecting. Oh, there it is, size 7. Okay, let's continue there. Size 7, we expected it to be 0. And it was. So just to show that it does move about, that both pointers do move about, I think we need to actually put a breakpoint in earlier and watch it and observe what's happening. That's what we're going to do. We're going to go through this, just quickly prove what is happening. So when we onqueue, we're checking the base, checking whether it's full. It's not full, of course, it's empty. We place contents, so this capital A, in the rear pointer, which is 0, and then the rear pointer increments. The rear pointer is not at 8, so it doesn't set it to 0, and it moves on. So we'll go down to G next. We'll press continue, and it'll just go and add the rest of the letters. And let us focus on what happens when we onqueue G. So it goes to the onqueue. It goes to the base class onqueue. It's not full, or we're checking whether it's full. It's not full. So the contents of C, so the G, are placed at the rear pointer position in the array. And if we hover over this stuff, we're able to see what's inside. So we've got the A, B, C, D, E, F, and then just some placeholders for the characters, just waiting to be put in. And we hover over it again after running that line, and see G's been put in. The rear pointer is going to then increment, and the rear pointer is 7, the Q length is 8, so it doesn't have to wrap around. We can check the size, and then when we try and put H in, let's observe what will happen when we try and put H in. So it goes to the onCue method, it goes to the base. Is it full? It is full because the rear pointer is equal to the length of the array, which is 8 minus 1, so it's 7. It is full, overflow error. Overflow error, so it's not going to be adding it, and that's why it doesn't add it. We do, however, DQA. Let's go and observe what happens there. So the DQ, we take a temporary, check if it's empty at first. The front and the rear aren't at the same location. We take a temporary copy of wherever the front pointer is, so front pointer is at 0, so it takes a copy of A, then it increments front pointer. Then in our child class, it checks whether the front pointer is equal to the length of the array, which it isn't, and it returns A. So it outputs A to the screen. So you can see that there, DQA. It's matching up. Then, when it comes to onqueuing H, the queue is no longer full, so we should see the rear pointer wrap around. So we're checking if it's full. It's not full. So the rear pointer at 7 at the moment, so it's at the highest point in the array. It's going to place an H, and we can see that happen. So we've got A, B, C, D, E, F, G, H. We've got all of them in there, and the rear pointer is going to increment. Now, because the rear pointer is 8 and the length of our array is 8, the rear pointer is going to wrap around to the front, and so our rear pointer will be at 0 and our front pointer will be at 1. So we'll see what happens when we try and onqueue I. We expected an error. So it tries to onqueue I. It asks, is it full? Well, the rear pointer is at 0, so it's not going to be equal to 7. So it passes that point. But the rear pointer is 0 and the front pointer is 1. And 1 minus 1 is 0, so it's saying that this is a full queue. So it doesn't put I in there, and it comes up with an error. So we could see there that the pointers do wrap around. Start again. And that's your intro to building your own circular queue. It's not a perfect circular queue by any means, but it's one particular example, and it gets the main aspects that you need for the onqueue and dequeue. It's very simple when you've got a linear, but it gets slightly more complicated when you've got circular because you're having to wrap it around. But it makes far more efficient use of memory when you've got some static data structures like arrays, ones that don't grow and shrink. It makes much more efficient use of memory.